So let's conclude our discussion on hashing. Hashing is a search method to be used when sorting is not needed in the application. Remember that the records are stored in your hash table, not in any specific order. What I mean is you cannot retrieve the elements from the hash table according to the key value. For example, if you were storing the values, the records in the hash table according to, let's say, the student IDs, it's not possible to get the records, student records, from the table in increasing order of the student IDs. So hashing will not provide you this. But what hashing provides is it will provide a search method which is able to find the element you're searching for if it's in the table. If not, at least it's telling you that it's not in the table in a very short time. So it is to be used when access time is your primary concern rather than sorting. In all search methods, we had the trade-off between time to access the elements versus the space complexity incurred by the method. So when there are no memory limitations, you can use the key as the memory address. So according to the key, you can directly jump to that address. So it will provide you the shortest access time, but it will typically require more memory to be used. On the other hand, if time is not your primary concern, then, for example, you can use sequential search, which is the simplest. There will be minimum memory usage in the case of sequential search, for example. However, it will take a lot of time to find what you're searching for. Hashing is a method that is between these two approaches. So it gives a balance between these two extremes. So it's a way to use a reasonable amount of additional memory. So it does have some extra memory consumption, but it provides you a reasonable time complexity. But in time complexity, it is not as good as direct memory access based on the keys, but the memory consumption, the memory footprint will be smaller. One important thing is how you choose the hash function. Choosing a good hash function is an art, and of course, it's science. But what I mean is, it is not so easy to find a good hash function. How you choose the hash function depends heavily on the nature of the keys, whether they're integer values or strings or something else. And also, for example, if they're integer values, what's the probability of this value appearing compared to another value? Are they evenly distributed, or is there any bias or anything else? So the nature of the keys and the distribution of these values is important in the selection of the hash function and the performance, of course. So the best course of action would be using separate chaining if the number of records is not known in advance. So when you're writing the program, you have no idea on what kind of a domain the user will be using your software. So you cannot estimate how large the input would be. On the other hand, if the number of records is known, or at least it can be somewhat predicted, and there is sufficient amount of memory that you can use, which means, for example, you're not using on very memory restricted systems like, say, sensors or embedded devices, then open addressing with its three different approaches could be used for a reasonable performance. So we have concluded and completed our course on object-oriented programming, and I hope you have benefited from the course. Remember that this course, the first half of the course, was an introduction to object-oriented programming, and in the second half, we used object-oriented programming, specifically Java programming language, but the main focus was actually, rather than programming itself, it was more on data structures. So as I said in the very beginning, this course was an introduction to data structures, or what you could call as data structures 1 course. Next semester in CMP 250, you will continue with advanced data structures. So I hope you all have a great summer, and in the times of COVID-19, please take good care of yourself during the summer, but also enjoy the summer. Have a nice summer.